Hi, my name is Alex Su. I'm in CYSE 211. I'll be going over the final project. The final projects that I've been working on is CVE-2015-7547 Glibc. I always having difficult time pronouncing this. Vulnerability. This vulnerability was initially get discovered by Google in around July 2015. This vulnerability basically what it does is there's a client trying to connect to a server, and when it connects, the client's connection will receive an error that says segmentation failure, which basically crashes the client's connection. And with that, that's basically a pretty big issue with clients trying to connect to their server and get their information and stuff. And here also some of the information that get more in depth. Google also provides proof of concept, which is code that we can use to replicate the attack. So this right here, CVE-2015-7547-clients.c, this file will be using as the client side, and this file, which is Python, it will be replicated as the server. So how we do this will be having the server standby, run the server file and have it ready standby, and then waiting for the client to connect to the server. Once it connects to the server, the client's side should theoretically receive an error that says segmentation, failed or false. So that means the attack actually works. And there are some requirements that we supposed to fulfill before we actually use this to perform this attack. So of course we have to download this code, and I'll be showing you having this code, execute this code and run it for both of these. And I'll also mention it later on, but before we actually execute the server, we have to change the IP. I'll also show you how to change it. We basically have to go on the terminal and using vi space dash /etc/resolv.conf, and then we have to use the code by the roots, so we can change the address, and the IP address within the Python needs to be the same as the line that I just mentioned. They need to be the same so it can be connected, otherwise it will show error. Secondly, there's also a requirement where when you have the glib, there's actually several versions, and this vulnerability only works in certain version. So the version is supposed to be a version of glib from 2.9 until the version 2.23. The machine that I have, it's 2.23, which I'll show you how you can see that before you actually perform the attack, and make sure the version is right, and all that kind of good stuff, so you can replicate. So yeah, let's go ahead and go go to the virtual machine. So to start, let's go ahead and check out the version. So by doing that, let me go and quit this one real quick. How you can check a version is typing apt.tude show Glibc 6. By doing so, it will show you your current version, which, as you can see, it's 2.23. This 0 Ubuntu 5. This one, for each version that you have for 2.23, they have different type of 2.23, so on and so forth. Specifically for the version that I have, you will see that it's actually being patched to against the Glibc vulnerability. So I was trying to find manually with different version of Glibc, but it doesn't really work. So I'll turn that into improvement of the lab. What are the ways that I can improve that to make it supposed to work? But besides, the client cannot receive segmentation faults while connecting the server. Otherwise, everything is fine. So this is just one of the main thing. Which version of the Glibc that you have, which is supposed to be again 2.9 version or in between 2.23. So after we check in the version, then we can go ahead and let me clear this again. Go ahead and change the IP address. So as like I mentioned, to connect between the server and the clients, we need to have the address correctly. So as you can see right now, I have the IP address set as 127.0.0.4. Initially, I have it as 123.0.0.1, but it might occur to you, it might not. But let me show you if I have it as 127.0.0.1. So if I have this, it spit out an error. That's that the system is saying, hey, this is it's being used. So I just figure, okay, if it's being used, then I would simply just pick another address, then it works just fine. So when we pick one of the address and then we stick to it, then we will have to use the VI space /etc/resolv.conf to change the address, from the terminal. So let's go ahead and do that. etc/resolv/f should be dot. So let me just close the terminal itself. So it's supposed to be resolv.conf. There's additional /. So that's why it doesn't work. Let me open new terminal. And it's like I mentioned in the presentation and the lab reports, when we change the IP address in the terminal, we need to be in the root. So we need to make sure we are in the root, enter your password. And since all of my documents are at my desktop, so let me just change the directory to a desktop. So once we are at the desktop, so let's go ahead and change the address. resolve, and then here, as you can see, I have already changed the address. When you initially open this up, you will see this is the initial address that you have. All you have to do is just simply comment it out. So initially was this, and then you just need to comment this out and then create another name server. And then in my case, I was using 127.0.0.4, so let's try .0 and see what does it do. And you might also come across this issue, and then you can, if that occurs, you can simply just change the different type of address, and then that should be successfully resolve your issue. I mean, that works for me, so it should be working across the board. What you will have to do now is basically compile the client file, which is .c, since we're finishing doing the setup for the server and set the address. So how we make the client's file executable will be make dash f and make so spell it wrong. So as you can see, it basically just automatically do GCC. You can also do GCC if you want, but we can simply just do make space dash f space make file. Make your life more easier, because you can also change the name of the program, but you just also have to make sure you change the your name in the make file needs to match, then it will work. So once we finish making the client.c executable, then we can go ahead and run the client. So we have already set up the server, so let's go ahead and set up the server, and then we use the clients to run connect to the server from the client. So by doing so, we just have to do Python and the file, which is, and then we can do tab, automatically fill out, and then p Python, and then enter. So as you can see, this says et.error, and then error, I guess that's number 98, address already in use. So that was the issue initially occurred to me. Let me also just screenshot this so I can also mention in the lab report. Okay, so that's the issue that I have. So what I did was simply just switch the address to whichever the last digit that you want. In my case, I just pick 4 and then save it. And now we have to go back and change the address in terminal under the name server. Enter I, and then you can do editing, and then exit out. And now we should be able to run the server. Boom! So now it's blinking. What this means is basically awaiting for the client to connect to the server. So now we just go to the other terminal, and remember that we already make the client file executable. So we simply just do that / CVE and tab, and there's your executable client program. So we just enter it. It shows that we receive the server receives it, and the clients can actually connect to the server. but there should be a fragmentation fault, and as like I mentioned in the lab, the reason why it's not having this might be because the version of my Glibc, it's actually patched, and I tried to find a different version, but I couldn't really find it. In the security, security side of the view, which is good. There's no more vulnerability with the Glibc for this specific attack. But I've been trying with different type of virtual machine, just couldn't get it to have those results that this lab was intended. But this is one of the difficulty that I've been facing. It's basically the unpatched version of Glibc, which is really hard to find. But yeah, if you have the correct version of the Glibc, then it will be vulnerable to this specific attack, and when the client trying to connect to the server is supposed to show fragmentation fail. So yeah, that concludes my lab, and thank you for watching.